Hello, and welcome to the September edition of our Azure Database for MySQL webinar. I'm Saurabh Kirtani, and I'll be your host for today. I'm a Senior Product Manager with the Microsoft Azure team, and today we'll have Teneil and Ram join us. First up, we'll have Teneil, who's going to be speaking about the business case for moving from on-premise MySQL to Azure's managed offering for MySQL Service. Next, we'll have Ram, who's going to be sharing with us about a new API they've just released, which can help you add context to your MySQL applications. And then I'll come back to do a recap of the latest feature releases and updates over the past month. And with that, I'm going to be handing off to Teneil. Hi, Teneil. Can you introduce about yourself and share what you're going to be speaking on?
Hi, everyone. I'm Teneil Lawrence, and I'm a senior product marketer here at Microsoft. And today I'm going to be talking with you about building the business case for Azure's managed service for MySQL. So running MySQL yourself entails heavy lifting and can come with high costs. So that's why we partnered with ESG to research the impacts of running MySQL on premises versus on Azure's managed service to quantify this impact and provide some insights to help customers make the business case for a move to Azure. According to ESG's research, a significant number of teams have had to bring in outside experts to help manage databases due to the complexity of management tasks. They found that the top challenges for MySQL users included data security, maintaining performance at scale, managing data growth, and ensuring high availability. Keeping up with compliance and security is especially tough on limited resources. Additionally, 74% of companies reported that database technology is evolving faster than they're able to adopt innovations. So all of this means a typical user is feeling the pain of managing MySQL in-house and is looking to modernize and offload those burdens. So if you're looking to make the argument for a move to Azure, there are some helpful insights in this report to help you make that case. So the study that we conducted with ESG modeled a 3-year scenario running several MySQL instances on-prem and on Azure's managed services. It included financial modeling and customer interviews, and the financial modeling included tracking hardware costs, infrastructure, software, labor, and downtime costs, which are common expenses for your MySQL instances on premises. The study found that organizations can cut MySQL costs by up to 54% over 3 years by migrating to Azure. And this reflects cost savings across hardware, software, and operations. On-premises deployments can incur significant capital and operating expenses. These are all expenses that Azure's pay-as-you-go model and included services can help eliminate. ESG's modeling shows that more than half of total costs disappeared after switching to Azure Database for MySQL, which is a fully managed platform as a service. So the how is pretty clear when you examine who handles what. So running MySQL on Azure shifts the responsibility for many of these tasks that you see on the screen from your team to Microsoft. And by eliminating tasks like database provisioning, monitoring, and scaling, which teams have to do on their own or hire outside help to cover, Azure's managed service frees up time for more strategic efforts, like by handling these tasks, plus hardware security, disaster recovery, and more. While on-premises MySQL means you're the DBA, you're the sysadmin, you're the hardware tech all in one, with Azure Database for MySQL, Microsoft takes over that heavy lifting. So that shift not only reduces effort and expertise needed, but it also provides more professional management for tasks that was once your headache. So let's explore some of these findings from the report. So the first key benefit highlighted in the report is the lowered total cost of ownership, or TCO. And this is achieved primarily on 3 fronts. There's the reduced licensing and tools cost. There's also the reallocation of database management tasks. And then finally, there is reinvestment in innovation. So many on-prem setups rely on MySQL Enterprise Edition for features like high availability or advanced backup. And that can cost anywhere from $5,000 to $16,000 per server per year. So with Azure Database for MySQL, you get these enterprise capabilities while running MySQL Community Edition, and that eliminates those license fees entirely. Additionally, any third-party backup or monitoring tools can be retired since Azure also provides those functions. This alone has been found to yield tens of thousands of US dollars in annual savings. The next up is the labor saving. So by offloading maintenance to Azure, organizations saw a dramatic reduction in the effort needed from DBAs and their IT staff. ESG noted an 86% reduction in administrative costs for MySQL after migration. In other words, if you used to spend 100 hours of DBA time per month on patching, tuning, backups, all of those other management activities, it might drop to about 14 hours on Azure. And this labor savings can be reallocated to your higher value projects. Finally, there is the reinvestment in innovation. So one interviewee described this move as wins on both sides of the equation. So costs went down and new opportunities opened up. So lower costs mean resources can be shifted to building new features, improving customer experience or other business initiatives, and that drives further ROI beyond just the IT savings. A second key benefit noted in the report are the performance gains. So the customer interviews that were conducted as part of the study highlighted several performance-related benefits. So Azure Database for MySQL includes features like accelerated logs and optimized infrastructure that dramatically improve database throughput and response times. ESG noted that on Azure, MySQL could leverage features like automated tuning and I/O scaling in ways that just aren't possible when you're running your MySQL instances on premises. So for heavy write workloads, users can enable these features as well as features like accelerated logs to further improve performance and lower latency. Internal testing showed that this could double throughput for certain workloads without any app changes. One company in the study saw their transaction volume triple while the query latency was cut in half. This kind of improvement meant their application could handle far more users and workload without any slowdowns. Overall, ESG measured up to 65% improvement in database performance post-migration in the scenarios that they analyzed. There's also on-demand vertical and horizontal scaling. So on-premises, scaling MySQL, it might take weeks. You might need to do things like procure hardware, schedule downtime, but in Azure, scaling can be done in minutes. You can easily scale up a server, add a read replica, and the platform can auto-scale storage and IOPS during traffic spikes to maintain that optimal level of performance. This fast scaling translates to better performance under load. So if an application's usage grows suddenly, Azure can respond immediately so there's no waiting or performance bottlenecks for your users. You can even scale down when needed so performance is matched to your needs at all times. Azure's managed service also comes with high-performance infrastructure. So global data centers and premium hardware give MySQL a boost. For instance, the memory-optimized tier uses faster CPUs, more memory, and NVMe storage, which yields superior transaction throughput versus typical on-prem setups. Even the general purpose tier benefits from low latency network as well as managed storage. Plus, Azure's intelligent features like query performance insights and index recommendations help get the most out of this hardware. The study found that Azure's managed environment often outperforms DIY MySQL because it's consistently maintained and optimized. On-prem performance can drift over time, but Azure's automated tuning, which uses AI to recommend indexing or tweak parameters, can keep performance high. One customer mentioned that they could now handle 5 times more workload after tuning on Azure. Also, tasks like updating to the latest MySQL versions happen sooner on Azure, whereas on-prem teams may defer upgrades due to the effort that upgrade might require. Finally, beyond cost and speed, Azure Database for MySQL improves the day-to-day experience for both developers and IT professionals. The ESG study highlighted how migration leads to greater agility, productivity, and reliability. So with Azure handling the database managers, developers, DevOps teams, they can move faster. So companies reported that their development efforts became 25% faster after migrating. When they were freed up from waiting on infrastructure or firefighting these database issues, teams could adopt more agile practices. So what this means is you're able to do more with less. So one customer was able to put out 8 releases per year compared to just 2 when they were on premises. And the fully managed nature of Azure MySQL, Azure Database for MySQL also enables your CI/CD pipeline. So spinning up a new test database or cloning a production snapshot for staging is much easier with Azure services, which then encourages more frequent testing and deployment from your dev teams. IT teams also found they could respond faster to changing requirements. Things like getting database deployments for new projects or adding capacity are no longer days-long tasks on a managed service. So unplanned downtime plummets after moving, and every interviewed customer agreed that there was a massive drop in incidents. The study estimates that approximately 70% fewer downtime incidents occurred post-migration. And this reliability means happier teams, it means happier end users, and just less 3 a.m. emergencies for IT. High availability, backups, and patches happen behind the scenes, so teams aren't scrambling to fix things or restore data. The consistency of operations avoids a scenario where one misconfigured server could cause an outage. Finally, although largely behind the scenes, the improved security posture, which is fully managed by Azure, gives IT leaders peace of mind. In practical terms, this means less time spent on security audits and patching vulnerabilities, since Azure takes care of that. You can redirect that time to building features or optimizing your data usage. And I just want to highlight just that Azure's managed services doesn't just outperform on-premises. It also stands apart from other cloud providers in several key areas. So we also conducted a Principal Technologies benchmark study a while back that compared Azure Database for MySQL's flexible server deployment to Amazon RDS for MySQL and Google Cloud SQL, and Azure came out on top in throughput and latency. In the test, they found that Azure managed service handled 50% more transactions per second than AWS and about 126% more than GCP. Azure also showed 33% lower latency than AWS and 55% lower than GCP. In real terms, this means snappier applications for your end users. And most importantly, during this test, when Principal Technologies calculated the price for performance, Azure was the best value. Their report noted customers could pay up to 54% less for the same performance with Azure versus alternatives. Also, if your organization already uses Microsoft Azure for things like VMs, app services, or security, using Azure Database for MySQL means seamless integration into that environment, which is a big win for the business overall. For example, Azure Database for MySQL integrates with Azure Entra ID for unified identity management, which is a capability AWS RDS MySQL lacks natively. You can also attach Azure Functions or App Service directly to Azure Database for MySQL with minimal configuration. This offers a holistic one cloud solution which can simplify your architecture and troubleshooting. Azure Database for MySQL is also integrated with Azure Migrate, which provides tools to help discover and move your MySQL instances to the cloud. Plus, the managed service is now available in more than 60 regions worldwide, which is often more regions than AWS or GCP for their MySQL services. And I want to take some time just to highlight one customer case study that was done outside of the ESG study, because these outcomes aren't just limited to that study scenario. We also have plenty of customer case studies highlighting these benefits. Edwarder, for one, is a Hungary-based education tech company that provides interactive business simulation courses to their customers. As their platform grew in popularity, they faced scalability and reliability issues with their on-premises MySQL infrastructure. They had limited geographic reach, hardware failures or maintenance meant class interruptions. Scaling up for peak usage wasn't quick or easy on their physical servers. Once they migrated to Azure Database for MySQL, their database now runs in an Azure region with the ability to serve users globally via Azure's network. They can even add replicas in other regions if they need it. They turned on Azure's backup services and high availability to protect against outages. They also realized a dramatic reduction in downtime. They were down to 48 minutes a year. This improvement meant their platform is almost never offline, ensuring students and instructors can rely on it for critical sessions. They're also better equipped to handle surges without any performance issues. And we also make adopting Azure Database for MySQL straightforward thanks to a suite of tools and services that assist with the discovery, assessment, and full migration workflow. We have new tools and capabilities to help you discover your MySQL environment and even estimate costs before moving through the Azure Migrate integration. You can also choose a migration method, whether you need to migrate offline, which is ideal for those smaller databases or just less critical workloads, or if you need online minimal downtime migration, that can be facilitated through the Azure Database Migration Service. We also help with piloting and optimizing the migration, as well as cutover and going live. And then once your databases are on Azure, we have tools to help you validate everything and track performance. You can leverage Azure Monitor to track performance and review just how well that migration is, how well your workloads are working after that migration. And if you want to test drive some of these capabilities before migrating, Microsoft offers some free trial credits so you can start experimenting. And the report that I mentioned is available at the link you can download. But thank you for your time and happy reading. I'll hand back over to my teammates.
All right. Thank you, Teneil. That was a great session. Thanks for your insights and thanks for sharing the study, which just tells how advantageous it is to migrate to Azure's managed offering for MySQL. All right, let's move on to the next session. Next up, we are going to be having Ram coming in. Ram is an engineer at Microsoft, and he's going to be speaking about a new API, which can help you add more context to your MySQL applications. With that, I want to invite Ram to the stage. Ram, can you please share an introduction about yourself, and please take it away.
Thanks a lot, Saurabh. My name is Ram. I'm an engineer in the Azure Database for MySQL team. And today I want to talk about this location-based capabilities REST API. So let's look at the problem at hand. Next slide. So MySQL Flexible Server is currently supported on about like 60 regions or 60 plus regions, all right? Some regions have 3 availability zones. Some regions do not have availability zones. We also support like 4 different server versions like 5.7, 8.0, 8.4, and 9.3, and different high availability configurations like same zone HA, multi-zone HA. Apart from this, if you look at the SKUs, right, the different SKU kinds that we support that are burstable, general purpose, business critical. And internal to that, we have Intel, AMD, as well as different cores, memory, storage, and backup retention period. So let's say you're a customer and you want to deploy MySQL Flexible Server in one of the regions. you would want first information as to what is available in that region, right? And does it have availability zones? Does it support all the versions? What are the SKUs that it support? Maybe some regions don't have AMD SKUs, right? What are all the different storage sizes supported? So you kind of need this information beforehand to plan, all right? And of course, you can look at the documentation and try to bring it up, but some of these things are dynamic in nature, in which it's like it might not be supported for some time, and it might be supported later, right? And so you would always want to get the latest information for okay, what are the things that are supported. And instead of reading documentation, we have a clean API now. So this is the problem at hand, and the solution is location-based capabilities REST API. It's a simple GET API. The URL has just subscription ID where you intend to provision the MySQL flexible server, as well as the location name. The location name is without spaces and lowercase, like East US or North Europe, wherever you intend to provision the MySQL flexible server, right? That is the location name. And you can call this GET API using Azure CLI, any REST API tool, or any other program like C# as well, from anywhere, wherever you can call the REST API. And it gives back a huge JSON as the response. All right. Now, what you see in this response is a value and capabilities. But the important properties are the supported flexible server editions, which give you the different side kind of SKUs and storage sizes supported. The storage editions, like minimum storage, maximum storage, minimum retention days, maximum, all these things, and the supported SKUs. And inside the supported SKUs, we have like each different SKU, Intel, AMD, all the different cores, whether same zone or multi-zone HA is supported, and all of those things. And some other properties are supported server versions. As I said, there are 4 versions, right? What are all supported in that? And supported geo backup regions, so that you can have like a geo backup, right? Though all the supported, you can plan for that geo backup as well. So you have this huge JSON. It's huge because we support so many SKUs, right? That's why you'll get like a pretty big JSON. So you can parse through this and understand like what is supported and what is not supported. Now, why is this API important, right? In the next slide, we'll see some reasons as to why this API matters. For first is deployment validation, right? Of course, you can always create a server. You will get an internal server error. You will have to open a support ticket and then try to understand why the server provision failed. All of this takes several days, all right? What if we can understand whether your server provisioning will fail by calling this API beforehand and understanding what is supported versus what is not, right? And so you're trying to provision a SKU in some region, and at the end it says like the SKU is not available, right? And so you can sort of plan all of these things, right? Whatever deployment validation you have, whatever you intend to deploy, you can see if that region supports all of the things before you provision the server. And the next advantage is automation and infrastructure as code. I know all of us have, like, I know we use Portal to provision sometimes, but mostly we have bicep templates, Terraform, support operator, like many different tools, Azure CLI, all different tools which provision the flexible server from a code, like infrastructure as code, right? And so you can have like call this API beforehand as a pre validation or something in the code itself, all right? That will give you insights as to immediately like saying this version is not supported or this queue is not supported, right? So you can make this part of infrastructure as code itself, and it'll give you more information before you like deploy the flexible server. The other advantage is resilience planning. So MySQL offers same zone HA and multi-zone HA, right? Some customers have a requirement to always have like zone redundant HA. And so if you're planning for that, then you can sort of use this API to understand whether zone redundant HA is supported in that location, and then try to provision the server based on your requirements, right? So that way you can plan the resiliency. The other advantage is developer, right? different developers have your application might be compatible with 5.7, 8.0, or 9.3, right? Whatever as a developer you are developing against, right? You can check if whether that region supports that version, right? Let's say you are migrating from on-prem, right? And your on-prem is 5.7. And in that region, you can check whether 5.7 is supported and then do the migration. So that's sort of a version check. And in terms of whatever you do, right, and the response you get, you can do all this sort of pre-validation. When do you know like if something is not supported is when the JSON does not contain the values, all right? So let's say in terms of supported versions, there are like 4 values, right? And you see only 3 values, the 4th value is not supported. In terms of SKUs, if you don't see any AMD SKUs, then AMD SKUs is not supported in that region. And there are some times when you don't get any SKUs in the response, all right? In that case, it kind of means like there is a restriction based on the region, and you can then open a support ticket to understand why is this API not giving back any SKUs, right? So at that time, our team can help and looking at the problem and seeing why it is like that. So in terms of the response, yeah, lack of values means like it's not supported, and you can, if you want support for something, then you can open a support ticket and ask like, I will require this for this particular region. Yeah. And I have created a script to call this API and just parse the response, JSON response. There's a bash script and partial scripts, which just takes the subscription ID as well as the location, and it gives back a neatly printed response from the JSON, passing the important values. Feel free to modify the script to according to your own needs, right? Whatever you wish to output, but this is just an example which you can include in your workflows, whatever you're using, right? Any pipelines that you have, bash or partial script to sort of add this pre-validation before you provision the MySQL flexible server. And I've written a blog also based on all of this information. And so, yeah, these are the different things that you can do and make your deployment more successful and have some reasoning beforehand if you feel like the deployment is failing. So feel free to use this API and ask any questions. That's all I have for today. Back to Saurabh.
All right. Thank you, Ram. So that link that Ram shared for his blog also contains the link to GitHub where he has posted these scripts. Now let's keep moving. I'll spend the next few minutes to cover a recap of the latest feature releases and updates over the past month. So first up, so MySQL 8.4 is the first long-term support release from the MySQL community since 8.0. And it brings a host of improvements in performance, observability, and replication management. Today, we are excited to announce that the MySQL 8.4 version is generally available on Azure Database for MySQL. With GA status, customers can now confidently deploy 8.4 for production workloads, backed by Azure's enterprise-grade reliability and support, giving you the confidence to run mission-critical applications on the latest version. If you're running on an earlier version, you can upgrade to 8.4 after your server receives the upcoming maintenance update, which is targeted for this month, September. This release empowers you to modernize your database infrastructure with the latest MySQL capabilities while maintaining high availability, scalability, and reliability. Next, you can now restore a server or create a read replica in a different subscription and resource group during the provisioning stage. In the absence of this feature, previously customers had to move resources to the desired subscription or resource group after provisioning, a process that added operational overhead and created scaling challenges when provisioning multiple resources. This enhancement enables cross-environment restores during the provisioning workflow, improved resource organization with minimal steps, subscription level separation to meet the governance and operational requirements of organizations, and provides isolation during disaster recovery. This had been an ask that had come in from some of our customers in the past, and we're excited to announce this is now available, so please go ahead and try this. Next up, so on-demand backups in Azure Database for MySQL are the manual backups that you configure yourself instead of solely relying on the system-initiated automated backups and schedule. You will now have the ability to delete on-demand backups that are no longer needed. This gives you a number of key advantages, such as better control and flexibility for backup management, optimizing and reducing the storage cost by retaining specific on-demand backups, and maintaining a cleaner backup inventory. Please go ahead and try this and give us feedback. So all these updates that I spoke about are available in our blog, the August recap blog, which we keep posting on our tech community page. This is the link for you to learn more about this, and it has more details about all the updates that I spoke about. With that, I want to do a quick summary of the documentation and resources that we have. Here are some of the links that you can go to learn more about Azure Database for MySQL. And you can always get in touch with us directly by sending an email. The email is at the bottom of your screen. Ask Azure DB for MySQL at service@microsoft.com. Any questions, feedback, comments, or assistance that you need with deploying MySQL on Azure, we are happy to assist you. Next, here are some of our social media handles in case you want to follow them if you're not doing them already across YouTube, X, and LinkedIn. And if you want to appear in a future webinar or just collaborate with us on Collateral, you can write to us on that same email ID. And please fill out this form to give us your feedback. It should just take a minute of your time, aka.ms/MySQL webinar feedback. And also share any other topics that you might want to see in this series going forward. With that, thank you for tuning in today, and we'll see you again next time.